Hello friends, this unit we're going to be talking about inequalities. This first section here is something that you've already done, so it should be a review for you, but solving inequalities and then graphing them on a number line. We have four types of inequalities: less than or equal to, greater than or equal to. Let me just remind you how these would look graphed. I always like to have my x or my variable on the left-hand side. I think it just makes it easier because then whichever way the inequality is facing is the way you will shade, but I'll show you both. So we can either have x less than some number or some number greater than x. So that's if x is on the right-hand side. Either one of those is going to be an open circle and shaded to the left. If we have x less than or equal to some number, or that means the same as some number greater than or equal to x, it's going to be a closed circle because it actually includes that number, and it's going to be shaded to the left. Now if we look at the greater thans, if we have x greater than some number or some number less than x, those mean the same thing. The bigger part is pointed toward the x. We have an open circle shaded to the right. If we have x greater than or equal to some number or some number less than or equal to x, again, the bigger part is still pointing toward the x on both of those. We have a colored in circle, and we shade to the right. When we solve inequalities, we solve them the same way we would solve an equation, with one exception. If you multiply or divide by a negative, only multiply or divide, not add or subtract, and only if you multiply or divide by a negative number. By a negative number, the symbol flips. So if it was greater than, it becomes less than. If it was less than, it becomes greater than. Make sure you have that written down. So let's look here. Combining like terms, we get 2p less than or equal to 10. Dividing both sides by 2, we get p less than or equal to 5. When I graph it on the number line, first of all, make sure you have arrows because the number line goes forever in each direction. I always put whatever the number is in the middle, so I'm going to put 5 in the middle and then just do 1 on either side of that. Because it's less than or equal to, we're going to have a colored in circle and we're going to shade to the left. Make sure your shading goes all the way to the arrow to show that it goes on forever, because every number to the left is going to be included in that inequality. This one, combining like terms, 9 plus 3 is 12. Minus 7 is 5. So 5 plus 5x less than 1 plus x. Get all of our x's on the same side. Again, I like to keep my x's on the left. So I'm going to subtract an x from both sides. 5 plus 4x less than 1. Take away 5. 4x less than negative 4. And then dividing by 4. Here I'm still dividing by a positive. The bottom number is positive, so I'm not flipping anything around. And I get x less than negative 1. So drawing my number line, we'll put negative 1 in the middle. 1 less than that is negative 2. 1 more than that is 0. It's x less than negative 1, so I have an open circle at negative 1, and I'm shading to the left. Let's look at this one. Using the distributive property here, 4 times 6x is 24x, plus 4 times 2 is 8. take away 7, less than or equal to negative 28, take away 5x. Combining like terms, 8 take away 7 is 1, so 24x plus 1, less than or equal to negative 28, take away 5x. Get all the x's on the same side. As I said, I always like to move my x from the left to the right, so I'm going to add 5x. So then I get 29x plus 1, less than or equal to negative 28. Take away 1 from both sides. So then we have 29x less than or equal to negative 29. And then finally, dividing by positive 29, I get x less than or equal to negative 1. So graphing this one, negative 1, negative 2, and 0. I have a closed circle at negative 1, and I'm going to go to the left because it's less than. Closed circle because of the equal sign, left because it's less than. Simplifying this one, 2 plus 4 times 4x is 16x. Take away 4 times 5 is 20, greater than 1 take away 3x. Combining my like terms here, 2 take away 20 is negative 18, plus 16x, greater than or equal to 1 take away 3x. Getting all my x's on the same side. Negative 18, greater than or equal, negative 18 plus 19x. Greater than or equal to 1. And then adding 18 to both sides, I get 19x greater than or equal to 19. Finally, dividing by 19, I'll get x greater than or equal to 1. So drawing this number line, again, I have 1 in the middle. Then we'll put in 0 and 2. We have a closed circle because it's greater than or equal to, and we're going to the right because it's greater than. These next ones are a little bit trickier. And let's see why. So combining these two, I get negative 4a less than or equal to 7 take away 3a. As I said, I like to keep my variables on the right, on the left, so I'm going to get rid of the negative 3a on the right. Now we have negative 1a less than or equal to 7. I'm going to divide by negative 1. Now this is a case where dividing by a negative, so this inequality symbol needs to flip. So my final answer then, a greater than or equal to negative 7. Again, the inequality symbol switched from being less than or equal to greater than or equal to. So graphing this, we still graph it the same way. The only difference is we had to switch that inequality symbol. So I have negative 8, negative 7, and negative 6. A closed circle at negative 7, and I'm going to the right. Let's look at one more like this. Negative 32, take away 3n, greater than or equal to. Remember, this is like a negative 1, so I'm really multiplying both of these by negative 1. Negative 1 times negative 8n is positive 8n. Negative 1 times negative 1 is positive 1. So now I'm just going to show you an example if I had the variable on the right side. So I'm going to add 3n here, just so you can see what that looks like. So when I have negative 32 greater than or equal to 11n plus 1. Take away 1 from both sides. Negative 33 greater than or equal to 11n. And then dividing by 11, we get negative 3 greater than or equal to n. Or this is the same thing then as saying n less than or equal to negative 3. If we look here, the bigger part is facing the negative 3, and when I switched everything, the bigger part was still facing the negative 3. So now when I graph this, I'm going to have negative 3, negative 4, and negative 2 on my number line. I have a solid or colored in or closed circle at negative 3, and I'm going to the left. These next two examples, the variables are going to completely go away, and we have two different situations. One of them, the answer is going to be all real numbers, which means we shade the entire number line. One of them, the answer is going to be no solution, which means we just leave our number line blank. So let's look at the difference between those. Combining like terms here, I have 4 plus 6a greater than or equal to 6a plus 4. So if you notice here, we have the same thing on both sides, but let's continue. I'm going to take 6a, take 6a, so then I'm left with 4 greater than or equal to 4. When that happens, you have to ask yourself if what you're left with is a true statement or not. Is it true that 4 is greater than or equal to 4? Is that a true statement? Yes, it is a true statement. It's not greater than 4, but it is equal to 4. So not greater than 4 is equal to 4. So since that is a true statement, my answer is all real numbers. How we graph that on the number line, I'll still have my 4, and we'll do 3 and 5. But how I would graph that is I kind of just shade the whole thing from one arrow to the other arrow. That shows that it includes every single number. All right, so again, if the variables go away and you're left with a true statement, the answer is all real numbers. Let's look at when the variables go away and you're left with a false statement. Negative 4 times 3m is negative 12m. Negative 4 times negative 8 is positive 32. Plus 5m less than 32. Take away 7m. Combining like terms on the left side here, I have 32, take away 7m, less than 32, take away 7m. So I'm noticing here I have the exact same thing on both sides. I'm going to add 7m to both sides. And what I'm left with is 32 less than 32, because the m's are going to go away on both sides. So what we're left with, 32 is less than 32. Is that a true statement? No, it's not a true statement. 32 is not less than 32. It's a false statement. So if you're left with a false statement, the answer is no solutions. And how we would do that on the number line is we would draw our number line. We'll still put in 32, 31, 33, but we'll leave it blank. There's no circles. There's no shading. We just leave it blank. So again, when the variables go away, You have to decide whether it's a true statement or a false statement. If it's a true statement that makes sense, your answer is all real numbers. If it's a false statement or a statement that doesn't make sense, your answer is no solution. Also, don't forget, if you multiply or divide by a negative, that you make sure to flip that symbol to its opposite.